MacMaths, let's do some maths today. Okay, we're in chapter 1 from the A2 textbook from Pearson. That's this one. And we're looking at chapter 1, the year 2 book, that is. And we're looking at chapter 1. I went through the proof by contradiction, not my greatest lessons. It's a bit of a tricky one to teach that. And that was the first exercise in the book. But after that, the whole book, the rest of the book is a whole lot simpler. I've missed out I'm missing out a couple of little bits on algebraic fractions because it's just what you did at GCSE. So I'm not going through that now. But you know, just to give you a bit of practice, go through those exercises, sort of 1B, I think it is, and C. But we're going on to partial fractions. So this is an A2 topic, partial fractions, and one that is it's a very important one. There is a use to this. You're unlikely to see standalone questions on the exam on partial fractions, but you may do. But really where it comes into its own is when you are integrating. I'll talk about that as we go through the lessons on partial fractions. Okay, so let's start. I'll just shut the door on and my study behind me, because if I leave it open the cat comes in and starts meowing at me. We've got one of these rescue cats and one of them is completely mental. Okay, so partial fractions, lesson 1. Let's start with just a fraction. So if you did something like, I don't know, a third plus a quarter, if you did that, and you go common denominators, and you get an answer for 12, so that's going to be 7/12, isn't it, when we do it? Okay, so that's what we're going to be doing. We're going to be doing, if you do the exercises before this one, before 1D, is doing just adding up fractions or taking away fractions or times and dividing fractions. But they're, instead of having just numbers here, digits here, they have letters. So it's algebraic fractions. And partial fractions is starting with a fraction like this, 7/12, and actually working back the other way. So can we split 7/12 into two partial fractions, you know? So if we started with 7/12, we never need to do this at GCSE, but if we started with 7/12, could we split it into, you know, two fractions that would add together to give us 7/12? Well, I suppose if you were to do that, you'd look for factors, wouldn't you, of the denominator? You'd probably instantly look, oh, I'll try, you know, thirds and quarters perhaps, because 3 times 4 is 12, and then work out what number would go there and what number would go there to add together to see if you could add two fractions together to give you 7/12. Well, that's what we're doing, but of course we're not starting with 7/12, we're starting with an algebraic fraction. Okay, the ones in this first lesson are going to be just normal fractions like this, where you have one bit of algebra over another bit of algebra. But the bit of algebra on the bottom is a bigger number. In other words, they're just normal fractions. They're not top heavy, they're not improper fractions. That's the posh word for it, isn't it? They're just normal fractions, so that's what we're going to look at. And I'm going to show you 2 ways. I'll tell you why they're uses once we've done one. But I'm going to show you essentially sort of 2 ways to do these. So let's start with one. So let's start with a question then. Okay. So my first question is, write, and if I give you an algebraic fraction, 6x minus 2 over, and I'm going to give you a quadratic on the bottom, but a quadratic that's been factorised. There we go. So this is like, like the one that I've just shown you. It's like the 7/12. You've got, you know, your bit on the top, and the bottom is bigger because this times this gives us an x squared. So you've got a linear over a quadratic, and a higher power of x means it's going to be a bigger denominator. Okay, so all the ones in this first section, and we're going to be doing questions from 1D in chapter 1, will be of this sort, where they're not top heavy, not considered top heavy algebraic fractions. Okay, right. Let's have a go at this one. So what we're going to do is this. We're going to split this up into its factors. So imagine this is the 12 here on the bottom, and you look at factors of 12. We went 3 and 4, didn't we, in my example? But this one, the factors are already there because we've factorised the bottom. So does this split into two fractions, okay, like that. There we go, they're the factors, where this is the same as some number that we can find over x minus 2, one of the factors, plus some number we can find over x plus 3, the other factor of the denominator. Well, yes, it does. I'm going to show you two methods for finding the a and the b now, okay? When I say two methods, I'm just going to show you two methods because there are two methods. I always use one of those methods, which is sort of the simpler one. Okay, but I'll show you both. But use the first method that I'll show you. Okay, here we go. So this first method. Okay, so this is method 1. Now I'm going to do this very long-winded. Not going to take very long to do it, but just so so it completely makes sense to you. I've got 6x minus 2 over x minus 2 times x plus 3. Now I know that this is equivalent to a over x minus 2 plus b over x plus 3. So that's how we start writing it. Now this here, to make this bit the same, what we're going to do is we're going to equate coefficients in a minute. So what I want to do is I can change this here and make it the same denominator, and if I did that I could times that by x plus 3, couldn't I, the bottom? So I could times the top by x plus 3, and this is the same fraction as it was before. I've multiplied the top and bottom by the same thing, and if I did that to this one, I've got an x plus 3, but so I times that by the factor that's missing, I can times the top by x minus 2. And now because these have got the same denominator as this, okay, and they've got the same denominator as each other, of course, when I've got 3/12 plus 4/12, I can write that as 3 plus 4/12, can't I? I can write the top bits over the same denominator, okay? So now I've done that, I can write that as a times x plus 3 plus b times x minus 2 all over that same denominator, which is x minus 2 times x plus 3. Okay, and of course that is equal, I'm going to write this whole side out again. That is equal to that, isn't it? Okay, so algebraically that makes sense to me. Okay, so we've said that this can be written as a over x minus 2 plus b over x plus 3, and we've multiplied top and bottom by the same number, and top and bottom are here by the same number. Okay, so that's legal, isn't it, mathematically? And then we can simplify it to this, so we get down to this line here. And it's the same with every partial fraction question you'll do, you'll end up just doing that. And now, of course, we're just equating, aren't we? So if all of this is equal to all of that, then of course 6x minus 2 must be equal, we'll use 3 lines, to a times x plus 3 plus b times x minus 2, mustn't it? So that must be equal to that there. Okay? So from this, we've got to work out a and b. And there's two ways of doing it. And method 1, which is, I think, the best way, is by substitution. And by substitution, what you do is you just substitute in a value of x to make the bracket 0, and it just cancels out one of your factors there, or one of your numerators. So for instance, nice and easy, let's just say that x is equal to 2. Now the reason I've chosen 2 and put 2 in there is because 2 minus 2 is 0. Okay, so if that bracket is 0, then b is 0 as well. Okay, and when x is 2, on this side we get 6 2s are 12, so we get 12 take away 2, and x is 2, 2 plus 3 is 5, so we would get 5a, wouldn't we then? And that would be 0. So we've got 10 equals 5a, and then of course divide by 5, and a is 2. That gets us our a. Okay, now we could put that in now. We know that a is 2, we could put it in, and we could rearrange. We could choose, but what we're going to do is we're going to substitute in another substitution. We can put x is minus 3, can't we? If x is minus 3, I'll do that there. That would make that bracket 0, and all of that is 0. So there we get, if we did that, we've got x is minus 3 in there. So 6 times minus 3 is minus 18, minus 2 is equivalent to, that's all gone, minus 3 minus 2 is minus 5, minus 5b. And that is minus 20 is equivalent to minus 5b. And dividing both sides by minus 5, you can see that b is 4. Okay, so now we know that 6x minus 2 over x minus 2 times x plus 3 can be written as 2 over x minus 2 plus 4 over x plus 3. And that is called partial fractions. Okay, and that's the method. Okay, the method of substitution. Of course, we've chosen 2 and minus 3, but actually we could choose any numbers, couldn't we, really? We could just choose 0 and 1 and put those in. We'd end up getting 2 simultaneous equations then, both with a and b, and that we could sort of solve. But it's just quick and easy to pick numbers that actually cancel out your brackets, one of your brackets. Okay. Now the reason we're doing all of this, actually, I will tell you now, is because later on in this textbook is integration, and integration at A2 gets a whole lot harder. It's one of the hardest topics students will find at A level. And if you've got to integrate that as a function, that would be very hard to integrate. But this is very easy to integrate these little bits here. So if we need to integrate something like that, we would split it into partial fractions first, and then these are quick and easy to integrate. Okay, these little bits here, that's why we're doing this. Okay, method 2. Okay, this is one that I never use. I like it, but I never use it. So let's get down to this line again here. If we get, so we're going to do the same thing, and we'd get down to 6x minus 2 is equivalent to a over x plus 3 plus b and x minus 2. I'm just checking that fits in the screen and just having a little look. Yeah, just about, I think. Okay, what you would do with this one then is you would go 6x minus 2 is equivalent to ax plus 3a plus bx minus 2b. So I've multiplied out the brackets. And then if you get your x's together on this side, you've got ax plus bx plus 3a minus 2b. Okay, and now if we factorise out the x, we get a plus b x plus 3a minus 2b. Now this side, you can see I've just done a little bit of maths on this. It's like the work that we do with vectors, isn't it? And now we can just equate coefficients, because if we're saying that this is equivalent to all of that, then what is in front of x on this side is the same as what's in front of x on that side. So now we've got an equation that a plus b must be equal to 6. Everything that's left is that, and that must be equal to the minus 2. So now we're saying that 3a minus 2b must be equal to minus 2. And we've got two simultaneous equations. If we double the top, if I double the top now, I'll do that underneath here. I've got 2a plus 2b is equal to 12, and I write my 3a minus 2b is equal to minus 2. So I've just doubled that now, just by GCSE elimination. And then if you add them up, the two up, you get 5a. That cancels out, is equal to 10, and you can see here that a was 2, which is what we've got in this, and then you substitute it back in, so b must be 4. Okay, so either or, but all mathematicians use this method, and that is partial fractions, and that's how you do it. Okay, I hope that makes sense, but you can watch me go through another couple of questions now. Okay, I'll do a couple more with you. Okay, so that was the first one. And you'll see that I do exactly the same thing. Okay, so I'll do these a little bit quicker now. So let's do another one. Let's have 8 minus x over x squared plus 4x. There we go. Okay, so first of all, that's my question. So my question will be, write this in partial fractions. Write in partial, oh, I'm not even going to write that. Okay, so let's do this into partial fractions. So a little bit of work with this one first, not a lot of work actually, is to factorise and get your factors at the bottom, your denominator. So factorise the bottom. So then this can be written as something over one factor plus something else over the other factor, which is x plus 4, so you can see. All right, and now I'm going to go straight to it because I've done these a million times. No, I'm going to go a little bit longer. I'm going to times this one x by x plus 4 and x plus 4, and I'm going to times this one by x and the top by x. So I end up writing all of that over this and this again. So I'm going to end up with 8 minus x is equivalent, aren't I, to a times x plus 4 plus bx. Okay, and we can simply go substitution, first substitution, I'm just going to go x is 0, because if I go x is 0, I've got 8 is equivalent to 4a, and the x is 0 cancels out the b. So first of all, a is 2. And then if I go x is minus 4, that cancels all of that out. Be careful, 8 minus 4 would give me 12 is equivalent to minus 4b. Okay, minus 4b. So therefore, b is equal to minus 3, isn't it? Okay, so now we can write out the answer. So this, as partial fractions, is going to be a, which is 2 over x minus 3 over x plus 4, because b was minus 3. And if you'd done it the other way around, it doesn't really matter. You know, you wouldn't write that. You wouldn't write minus 3 over x plus 4 plus 2 over x. You'd write it like that, wouldn't you? Okay, and there it is, as partial fractions. Easy to integrate, easy to integrate. Wouldn't be easy to integrate that. This is later on. It won't. We've not taught you how to integrate those, even those ones yet. Okay, so there's one that you had to factorise, and of course you can. I'll do one more with you. Okay, you can get ones like let's say 2x minus 14 over x squared plus 2x minus 15. So this is just the same as the first one, but you can see the bottom bit here isn't factorised. So that of course is equivalent to 2x minus 14. Let's factorise this bottom bit first and get our two factors. So what are 15? It's going to be 5 and 3, isn't it? So it's going to be x plus 5 and x minus 3. So those are our factors. So we know that that can be written as a over x plus 5 plus b over x minus 3. Okay, so this can be factorised to that. I've factorised the denominator, and then the denominator, then we've split it up, and this can be written in partial fractions of a plus b. And going straight to it now, you can see that 2x, if I did all of that nonsense, all that garbage that I've just been doing, I'd end up with the line somewhere down here, wouldn't I, of 2x minus 14 is equal to, I'm just going to pass that phone on to my family. Sorry about that. Thank you. Sorry, that's probably my agent on the phone. Marks and Spencers have been contacting me. They want to put my adverts, their adverts on my YouTube channel. Okay, so 2x minus 14 is equivalent to a times x minus 3, because you can see I'd be timesing this one by x minus 3 and the top by x minus 3, plus b times x plus 5, because I'd be timesing the bottom by x plus 5 and the top by x plus 5. Okay, so I would get down to that line, and from that line you can see what I'm going to do, can't you? I'm going to go straight away with x is equal to 3. Okay, so that's 6 minus 14 there is going to be equivalent to, now when x is 3, we get 0, so 0a, it's gone, 8b. And look, when I go 6 minus 14 there, you can see that you got this on an exam, you've got it right, don't you? Because it works out nice. Minus 8 is equal to 8b, so b is equal to minus 1. So when I come to do it, I'm just going to put, I'm not going to put plus minus 1 on top, I'm just going to go minus 1 lot of x over 3. Okay, and if I did x is equal to minus 5 there, for this one, I've got 2 times minus 5 is minus 10 minus 14, so that's equivalent to minus 24 in a minute. And we've got x is minus 5, so we've got minus 8a, and all of this is 0, so we've got minus 24 is minus 8a, divide by both sides by minus 8, so a is 3. So as partial fractions, all of that is going to be, a was 3, so 3 over x plus 5 minus 1 over x minus 3. Okay, and that's the first section. So have a go at those, get a bit of practice. They're all the same. There is some factorising for you to do, like on this one of the denominators, but none of them are top heavy. All of these now are from exercise 1D. Now this is on page 11 in the textbook, and actually I have done question A, and I did question G, and I did question H from the actual question 1. There's lots of parts to it. So there it is. That's the page I've been doing, and I've done those 3. Okay, but you can see that even when you get down to the bottom and the problem there, that's just, you got, I won't do that one for you, but if I just look that out a minute, it's got down to these harder ones, and on the bottom it's got 6x squared plus 7x minus 3 on this problem over, that looks easy, x cubed minus x. So it's, the last and the hardest one, gets down to that. Okay, well this bottom bit is going to be, if you factorise it and take out x, you're going to have 6x squared plus 7x minus 3 all over x and x squared minus 1, aren't you? And be careful, x squared minus 1 is x, remember it's x plus 1 times x minus 1. So there we go. So that is 3 partial fractions of a over x plus b over x plus 1 plus c over x minus 1. Okay, so there's a bit more work to do there, because when you put in, say, a substitution of x is 1, okay, it's not going to get rid of all of it. You're going to end up with simultaneous equations on that one, but you can do that. It's all right. You're clever enough to have a go at that one on your own. Okay. All right. Okay. Have a go at those. Do you want me to do that one? Should I do that one? Yes. Do you want? I will. I'll just do this, because this is the problems, and this is question 7, and as hard as it gets in this exercise. So I'll just finish that one off for you. Okay. You can put it on pause or stop it now, because I'm just starting to ramble, aren't I? Okay, so this was questions 7 in that exercise 1D. Okay, if we get down to this stage, of course, now let me show you this. Okay, Right, we've got now, if I move this up for you so I've got some room, we've got 6x squared plus 7x minus 3. We started off with that, didn't we? Okay, no, we started off with x cubed minus x. We factorised to that, and we said that this is equivalent to this. All over x are 3 factors. So how do we, the question is how do we do 3 factors, and that's equivalent to a over x plus b over x plus 1 plus c over x minus 1. Okay, it's easy for me to say, oh yeah, just have a go at that. Okay, but when you're inexperienced, and you haven't had the experience of seeing it, it's not so easy, is it? Okay, so here we go. Let me do this one for you. So we want to change this x into all of that. So what would we do with this x? We times it by x plus 1, but also by x minus 1. So we could write it as a over x times by x plus 1, x minus 1. Now it already had the x on the bottom, so we've got to times all the top by x plus 1 times x minus 1, the other 2 factors. Plus, what do we have to multiply this by to make all of that? Well, we've got to multiply it by the x and the x minus 1. So on the top, we're going to have b times the x minus 1, but also by the x, plus the c times the x plus 1, which is the 1 times by the x. So you get that over all that stuff. So you end up with 6x squared plus 7x minus 3 is equivalent to a times x plus 1 x minus 1 plus b times x minus 1 x plus c times x plus 1 x. There we go. Okay, I hope that you understand how I've got to there. Okay, so it's just the same as what I did with the first, very first question, but I've just got more factors, so I've got 2 bits to multiply the top and bottom by, the other 2 missing bits, and it gives me a longer equation. If I do the substitution for this now, well, let's just start with x is equal to 0. If x is equal to 0, all of that goes, so I've just got minus 3. Now if x is equal to 0, of course 0 means all that is gone and all that is gone. Okay, so then I'm only left with this bit here. So 1a times 1 and x is 0 times minus 1. So 1 times minus 1, so minus 3 is equal to minus a, so a is equal to 3. That's when x is 0. If I did when x is 1, I've got 6 plus 7 minus 3, haven't I? Putting it into there. And that is going to be equivalent, well, when x is 1, this goes, doesn't it? Because 1 take away 1 is 0, so all of that is going to be 0. And when x is 1, that's all going to be 0. And when x is, because 1 take away 1 is 0 there, when x is 1 on here, we've got 1 plus 1 is 2, so we've got c times 2 times 1. So 6 add 7 is 13, take away 3 is 10, is equal to 2c, so you can see that c is 5. Okay, and then the last one I'm going to go x is minus 1, and minus 1 squared is 1, so that's going to be 6 minus 7 minus 3 is equal to, now when x is minus 1, this is 0, okay, so all of that is gone. This one here is minus 1, so it's minus 2, so that's b times minus 2 times minus 1. And x is minus 1, so that's all 0, so that's all gone. So then we've got 6 minus 7 minus 3. So 6 minus 7 is minus 1, minus 3 is minus 4, is equal to, and you can see here that a minus times a minus is a plus, so is 2b, and divide by 2, so b is minus 2. Okay, So now, if we just rub that out, my answer, if I just go straight to it here but rewrite it out, we've worked out A is 3, it's a positive number, so I'm okay with that. B was -2, so we can put -2, and C was 5. The magic of having a whiteboard and being able to rub it out with your finger. There we go. So that was your sort of hardest one on the in the exercise, this one here, and it breaks down to this, and of course, you know, that can be written on the end if you want. You can have 3 over x plus 5 over x minus 1 minus 2 over x plus 1. Okay, but that's the method. All right, hope you enjoyed that. Hope you understood it actually. Whether you enjoyed it or not, it's another thing. Who wouldn't enjoy maths anyway? Okay.